We'll start a new lesson in real numbers. So we'll take first a set of problems. Given decimals, we will express the decimal in the form of A by B, where A and B are integers. So how we can express this point 375? We can straight away express 375 multiply both sides by 1000 and divide, but there are so many common factors with this. So we have to eliminate all the common factors. You divide by 5 both sides. 7 5s are 35. 5 5s are 25. Divided by, if you divide by 5, it's 200. Oh, again this is divisible by 5. You can divide by 5 is equal to 15 divided by 40. Or you can further divide by 3 divided by 8, then divide by 5. So this is the, so we have to divide and divide the factors in such a way we get prime numbers. And cancel all other common integers between the numerator and the denominator. So 3, 4, 3 by 8, that's how we. So we'll go to the next problem. Similarly, this 104, we can just factor 104 divided by 1000 is equal to 52 divided by 500. Am I correct? So you can further divide by 4 both sides is equal to 13 by 125. So 13 is prime number. So denominator doesn't matter. So we know there is a pattern, See, this is of the form, the first problem, it's the form 3 divided by 2 cube. So denominator 2 cube is. In the next case, we can write this as 13 divided by 5 cube. So we'll do some more problem. What is this? 0.0875. So we will do some exercise so that we'll get used to it. Now this is equal to 8 multiply and divide by 10,000. So we can now do 875. You can write 25 multiplied by 35. The number 25 divided by 40 multiplied by 10. So this 25 will get cancelled. Now this is 7 5s or this is 8 5s also is equal to 7 divided by 2. So this also further we can, this is 10 we can add 2 multiplied by 5. 2 to the power of 4 multiplied by 5. So the denominator should be in terms of 2 to the power and 5 to the power. For the purpose of deciding whether the decimals are finite terminating or not. So we'll try one more problem. What is this 1 by 7? So we'll try what if 1 by 7 is equal to, we'll try to work it out. So now you add 1 0. So 10 minus 5 is 3, 3 0, 4 7s are 28, and then 2, 2, 0, 2 sevens of 40, and then 6, 6, 0, 8 sevens are 56, you get 4, 4, 0, 5 sevens are 35 minus 35 equal to 5, again 50, it's 7 sevens of 49, get 1. So you come back to the original position. Now again if you add 0, the same thing will be repeated. So these terms will not end. Now it will continue like this: 4, 2, 8, 5, 7. Again it is 4, 2, 8, 5, 7. Like this it continues. So it is, so here this it is not terminating. So the next problem we will apply, we have to find out whether the fractions are terminating or not. As per the Euclid's formula, the denominator should be of the form 2 to the power m, alright, 5 to the power n. Then it's terminating, otherwise not. So in this case, see 17 divided by 5, or you can write it as 17 divided by 2 cube. So what about q? Denominator, it is 2 to the power m, some power is there. So you can take it as 5 to the power 0. So it's terminating. If you actually divide, you get the answer 2.125. We can divide and check. The next problem, 64 divided by 455. Now 64, when you think of 64, you can write as 8 square divided by, now 5 multiplied by, it's 91. Or you can write, so this 91, so denominator is not of the form 2 to the power of something. The 91 is odd, it cannot become 2 to the power. So denominator is not of the form 2 to the power m into 5 to the power n. So if you divide, it is not terminating. If you actually work out, it goes like this: 0.1406593, like this. It goes on. You just try, make an attempt of just divide and check. Next problem is 15 divided by 1600. This we can, 15 we can add 3 multiplied by 5. So bring all the numerator everything to the in simple form. Cancel the common factors, and we can get it to the form 2 to the power or 5 to the power denominator, so that the problem is easy to solve. What is the denominator in this case? It is 20,600 is divided by 25. 25 divided by 64. If 100 is divided by 4, this is multiplied by 4. That's all. 60 multiplied by 4. So this 5 is a common factor. This is 5. Now this is equal to 3 divided by 64 is 2 to the power 6. 8 8 or 64. 8 is 2 cube. 2 cube multiplied by 2 cube equal to the power of 6 multiplied by 5. Therefore, so if you divide this fraction, it is t terminating. You can divide and check what is this 15 by 1600. So the answer is terminating. So what is the heading? You have to find out whether when expanded, whether the following fractions are terminating or not. So next problem is 13 divided by 3125. So 13 divided by 25 multiplied by 124. Sorry, it's 125. Is equal to 13 divided by, this is 5 square, this is 5 cube, so it is 5 to the power of 5. Now, in this case, we may get a doubt whether it is terminating or not. Now, in this case, we'll actually divide it and check. Now, in this fourth problem, it is says the denominator is of the form 2 to the power m. Here is 0 multiplied by 5 to the power n. Therefore, the decimal is terminating decimal. So if you divide, actually you will get something like it is 0.0041216. Now this you can just try. The next problem, 29 divided by 343. So denominator is odd. So there is no power of 2 and or and also not divisible by 5. Therefore, the decimal is not terminating. You can actually divide and check. The next problem is 23 divided by 2 cube multiplied by 5 square. So 2 to the power of m, 5 to the power of n. Oh, this problem is repeating. I will cancel one of the problem. So this is decimal is terminating because denominator is of the form 2 to the power of m into 5 to the power of n. By denominator of the form, therefore it's terminating. So we'll just straight away go to the next problem. 6 divided by 15. So if we divide both sides by 3, it is equal to 2 divided by 5. So this we know the answer. So decimal is terminating. So what is 2 divided by 5 is equal to 0.4. So we'll do some more problems in this. If something like 35 divided by 50, what you will do? Divide both sides by 5. So this is equal 7 divided by 10 or is equal to 0.7. So we know the answer. So it is decimal is terminating. Terminating decimal. Okay. And also by Euclid's formula, it is 2 to the power 1 and multiplied by 5 to the power 1. So we are say by Euclid's theory, denominator is, so therefore